Hi students, in this video we're going to be covering angles and the angle addition postulate. For this video you will need a calculator. So our objectives are to review basic facts about and use the angle addition postulate. So an angle is the space between two intersecting lines or rays. The point of intersection of the lines is called the vertex. So we have this ray 1 that's blue and ray 2 that's red. And the point where they intersect is called the vertex. It's important to note that both sides of the angle don't have to stop at the vertex. It means that we would just get multiple angles from one vertex if we have a pair of intersecting lines. So now we would have, so this space that I'm drawing an arc, this represents an angle. And so now we have four different angles. We have angle 1. We can say that little space is angle 2. We have this other space that we'll call angle 3. We have this other space that is angle 4. So an angle is just the space between intersecting lines. So when we name an angle, if there's only one angle that comes from the vertex, we can just call that angle by the name of the vertex. So for this first picture, we can just say we have angle B. That angle is angle B, and we're using this symbol, almost like a less than symbol, but one side is flat, parallel to, we'll say like parallel to the ground. So we have angle B. That's how we name an angle where we have only one angle coming from the vertex. So if we have multiple angles coming from the vertex, we have to use 3 letters to name the angle. In the picture on the right, if I told you we had angle S, you wouldn't know if I was talking about, for instance, this angle, or maybe that angle, or maybe even that angle. So when we have an angle that comes, multiple angles that come from one vertex, we need to use 3 letters to name that. So we're going to outline some angles in different colors so we can see what their names will be. So the angle that I have, where the interior is green, we're going to call that, so that angle is going to be either angle OSN. When you use 3 letters to name an angle, the vertex needs to be the middle letter. And since S is the middle letter, since S is the vertex, we're going to have angle OSN. And that's the same as angle NSO. The outside letters, their order, they can be, it doesn't matter. The middle letter is going to have to be the vertex. So angle OSN and angle NSO are the same angle. So those angles are congruent. And so then we have this other angle here, this space in here. We have angle NSI, and that angle is congruent to angle ISN. Those are the same. And then we have, if we outline this angle here, we have angle ISD. So angle ISD or angle DSI. Those are the same thing. So we have 3 smaller angles. And then we have this very big angle on the outside. So we have angle OSD. I'm going to call that angle OSD or angle DSO. So when we name an angle using 3 letters, that's probably going to mean we have multiple angles coming from the vertex. So the angle types that we have an acute angle, right angle, obtuse, and straight. I'll let you read that. It's pretty straightforward. And then we have angle relationships. We have complementary angles. They add to be 90. It's important to note that complementary angles do not have to be adjacent or beside each other to be complementary. The sums of those 2 angles just needs to equal 90. And the same thing for supplementary angles. They're just 2 angles whose sum is 180. The angles do not have to be adjacent. Just the values have to add to equal 180. So some new notation, when we see the letter M, angle A, that's going to mean the measure of angle A. And if we see the same thing with 3 letters, if we see the measure of angle ABC, that's going to mean the measure of angle B that is drawn with lines AB and line segment CB. So for our purposes, any angle that we deal with, all of the values are going to be positive, and sometimes we may end up with decimal values for our angle. The angle addition postulate is going to basically say that if we have a large angle and the adjacent, if we have a large angle in which it's divided into 2 smaller angles, the biggest angle is the sum of the 2 smaller angles. So using that 3-letter notation, what we can say is the measure of angle ABC. So the measure of this angle on the outside, the measure of angle ABC, that's going to equal, let's use some different colors. Well, I guess we can use blue. So that's going to equal the measure of angle ABD, which is the blue angle, plus the measure of angle DBC. So if we take the 2 small angles and add them together, we should get the larger angle. And what that's also going to mean is that we only need to know 2 angles to find the third. Let's make that note. We only need 2 angles to find the third missing angle. And so our examples are going to explore that concept. So the first angle that we have is the measure of angle FCD is 67 degrees. The measure of angle BCF is 85, and we need to find BCD. So let's label everything. So the only thing that we need to do is label everything. Moving forward, you're going to hear me say this a lot. We need to label all of our information. So the measure of angle FCD, so FCD is this angle. That's 67 degrees. And then angle BCF, let's go with a different color. So, let's not use orange. So angle BCF is B to C to F. That angle is 85 degrees. So it seems like we have those 2 smaller angle values given to us, and we need to find BCD. So BCD is going to equal this outside angle. So we already know that the measure of angle BCD is equal to the measure of angle BCF plus the measure of angle, we called it FCD. And so the measure of angle BCF, that's 85 degrees, and the measure of angle FCD is 67 degrees. So we can just add those 2 values together, and we will get 152 degrees. All right, so the angles are adjacent. We just add their values to get the biggest angle, and we're done. So example 2, we have the measure of angle IGH is 116. So let's label that. The measure of angle IGH is 116 degrees. And then we have the measure of angle FGH. So the measure of angle FGH, this angle I'm outlining on the outside, that value is 156 degrees. And we are trying to find the measure of angle FGI. So angle FGI, we don't know, so we're going to call that X. So we can solve this equation. 116 plus X is equal to 156 degrees. And we can simply subtract 116 from both sides, and we would get X equals 40 degrees. So we can just pencil in 40. And so that makes sense. 116 plus 40, 156. For example 3, we're going to get into some basic algebra. We have angle GFM. So angle GFM, that is 4x plus 11. And then we have angle MFE. So angle MFE, we'll even underline that in blue, is 7x plus 10. And we also know that angle GFE, the outside angle value, is 109 degrees. So then we can make an equation that says that those two things must be equal. So our equation is going to be 4x plus 11, one small angle, plus the other small angle, and they equal the biggest angle, 109 degrees. So we need to combine like terms on our left side. So 4x plus 7x, that's going to be 11x, and 11 plus 10 is going to be 21. So 11x plus 21 equals 109 degrees. And so next we subtract 21. We get 11x equals 88. And we divide both sides by 11. And so we get x equals 8. Now notice our work said we need to find the measure of angle MFE. So MFE, that's going to be 7 times 8 plus 10. So that's 56 plus 10, which is 66. Now I encourage you to go back and check all of your work so that you can make sure all of the values work. So that means that GFM is going to be 4 times 8 plus 11, which is 32 plus 11, which is 43. And so we know that GFE is the two smaller angles. So 66 plus 43 is 109. So all of our work checks out. And for our last example, we're trying to find the measure of angle DEF. So the measure of angle DEF in degrees, we already know we have an expression for it. That's 57x plus 3. We have angle DEL. So angle DEL, that is 19x plus 2. And we have angle DEF, angle LEF, which is 115 degrees. And so now we can make our equation where we have the green and the red angle are going to add to be the blue angle. So 19x plus 2 plus 115 is equal to 57x plus 3. So the first thing we can do is combine the 115 and the 2. So we get 19x plus 117 equals 57x plus 3. So next, let's say we subtract 57 from both sides. So we get minus 57x minus 57x. And that's going to give us negative 38x plus 117 equals 3. And then we subtract 117 from both sides. So we're going to have minus 117 minus 117. So we get negative 38x equals negative 114. If you want to, you can throw that into your calculator. So we're going to get x equals positive 3. And so we need to find the measure of angle. The instruction said find the measure of angle DEF. So we're going to substitute the 3 in. So we have 57 times 3 plus 3. And that's going to equal 171 plus 3. So 174. And again, you can check the rest of your work. If we find the measure of angle DEL, the measure of angle DEL is going to equal 19 times 3 plus 2, which equals 59 degrees. So let's go back and pencil in those values. We know that value is 59. And we got DEF to be 174. So a quick check is just to add the 59 and 115, and if we get 174, our work is correct. And that's exactly what we get, so we know our work is correct. All right, so that's going to conclude our video for the angle addition postulate. We covered the basic types of angles. We discussed how to name angles, and most importantly, we discussed the angle addition postulate, which is just given a large angle broken into adjacent smaller angles. The largest angle is the sum of all of the smaller angles, which is what we did in example 1, 2, 3, and 4. All right, so thanks for watching.